Here we are on question 41 on the second semester final review, and we're taking this section as square roots. The square root of 25 is 5. The square root of x to the 16 is x to the 8th. Remember, when you square root, you divide exponents by 2. When you take the cube root of 1,000, because 1,000 is 10 times 10 times 10, 3 times, the cube root of 1,000 is 10. On 43, we're taking the cube root of negative 512. When it's a cube root, we can take the root of a negative. I get negative 8. X to the 6th cube rooted is x squared. For number 44, the fourth root of 81, because 81 is 3 times 3 times 3 times 3, we know that the fourth root of 81 equals 3. On number 45, since the negative is out front, we can leave it out front. The fourth root of 625 is 5. For number 46, we're going to simplify these answers. We want to find a square root that divides into 294 and 294 divided by 16 divided by 25, 36, 49. So this is 49 times 6. Square root of 49 is 7 root 6. For number 47, 8 is 4 times 2. And x squared y. We can bring the 4 out, it becomes the 2. We can bring the x squared out, it becomes the x. Actually becomes absolute value of x. And we can leave the 2 and the y under the radical. Remember, the half power is the same as the square root. The square root of 1 over 64 is the same as the square root of 1 over the square root of 64, which gives me 1/8. On 49, we're simplifying this rational exponent. We know the top number is the power, and the bottom number is the root. So I am taking the cube root of 64, taking that answer to the fourth power. The cube root of 64 is 4, and 4 to the fourth power is 256. On the bottom here, we're going to use the product rule to multiply. Assume all variables are positive. So if we're going to multiply these things, we can take the cube root of 27 is 3. Cube root of m cubed is m. Over here, cube root of 125 is 5. Cube root of m cubed is m. Simplifying, I get 15m squared. On to the last page. Let's take a look at number 51. We know that we can write these under a single radical because they're to the same root, so I get 686 x to the 7th over 2x. Simplifying that, I get the cube root of 343 x to the 6th. We know that the cube root of 343 is 7 x squared. On 52, again, you can't add things that are different radicals, but I bet you if we simplify some of these things, we're going to be able to take some things out. 49 times 3. When I take the 4 out, I'm left with 2 root 3 plus, when I take 49 out, I get 7 root 3. Now that they have the same radical part, we can add them together. 2 plus 7 is 9 root 3. Remember, the radical doesn't change when you add or subtract, just when you multiply. On 53, we're doing the same thing. We know that 128 is 64 times 2. This is 16 times 2, and this is 25 times 2. Bringing those out, I'm going to have the negative 3's already out there. Multiply that by the square root of 64, which is 8 root 2, plus the 2 is out there. Bringing out the 16, that's a 4 root 2. And the negative 4 is there. Bringing out the 5 root 2. Simplifying, I get negative 24. Notice that we multiply the number that you bring out with the number that's out there. Negative 24 root 2 plus 8 root 2 minus 20 root 2. I get negative 36 root 2. In this one, again, we can't subtract things that have different radicals, so we're going to have to bring some stuff out. Here, this is 27 times 2. Since we're cube rooting, the cube root of 27 comes out as a 3, so I get 17 cube roots of 2 minus the 3 comes out. I get 9 cube roots of 2, so 17 minus 9 gives me 8 cube roots of 2. For question 55, we're going to distribute this radical. When we multiply radical times radical, we get the radical 20 plus radical 4. We want to simplify that. Radical 20 is 4 times 5. The 4 is going to come out as a 2 because you square root it, plus 2. Can we add numbers with radicals and ones without? No. So this is my final answer. On 56 here, we're going to do some foiling. Square root of 12 times square root of 12 is square root of 144. I know that's 12, but we're not going to simplify till the next step. Outside times outside, I get negative 3 square root 12. Inside times inside is positive 3 square root 12. And last times last is negative 9. If I would have recognized that they were conjugates of each other, I would have known not to do the multiple inside times inside and outside times outside, because they're always going to be opposites. Let's simplify. Square root of 144 is 12. 12 minus 9 is 3. In 57, we're squaring this. When you square, that means to multiply by itself. So I'm going to rewrite it as two binomials multiplied by each other. And I'm going to FOIL. 5 square roots 11 times 5 square roots 11 gives me 25 square roots of 121. Outside times outside is 25 square roots of 11. Inside times inside is 25 square roots of 11. And last times last is 25. Putting some like terms together, simplifying, I can get 121 square rooted is 11. 11 times 25 is 265. 25 square roots 11 and 25 square roots 11 gives me 50 square roots of 11 plus the 25. Let's put the 265 and the 25 together. I get 290 plus 50 square roots of 11. When you multiply things that are negative under the radical, we need to bring out the negative first. So I get I square root 5 times I square root 6 gives me I squared square root 30, which is I squared is the same as negative 1. So I get negative square root of 30. Let's stop there.